Hello friends, welcome you all. Today we are going to learn about the exercise number 8 of course ENTO 232 for the semester 3rd. The name of the exercise is the chemical control of the IPM. In that chemical control we will study about the different insecticides or pesticides and their formulation available in market. Here, basically, the insecticides or the pesticides, it is basically grouped into four major categories. In that, the first one is based on the usefulness, then based on the chemical nature, based on the mode of entry, and the base of the mode of action. So let us see one by one. The first category is based on the usefulness. In that, there are near about the 12 insecticides includes in that insecticides, rodenticides, acaricides, avicides, molluscicides, nematicides, fungicides, bactericides, herbicides, algicides, arboricides, and pesticides. Basically, the insecticides mostly used to kill the insects, rodenticides mostly used to kill the rodents or rats, acaricides also called as miticides against the different mites and ticks, herbicides specially used to repel or to kill the birds, molluscicide mostly used against the soft bodied insect like a snail and slugs, nematicides mostly used against the nematodes, fungicide for fungus, bactericides for bacteria, herbicides for weeds, algicides for algae, and arboricides for to kill the trees and shrubs, and last one is the pesticides. It is mostly used against to kill the fish. This is about the insecticides based on the usefulness. Second category is based on the mode of entry. It means that how the insecticide it is enter into the insect body. The first one is stomach poison. In the stomach poison, this insecticide is mostly used to kill the insects which having a chewing and biting type of mouthparts like a grasshoppers, beetles, and the caterpillars. After the application of the stomach poison insecticides, they when infested when a treated plant it is ingested by the insects, they directly act on the digestive system and to cause the death in the insects. In that, basically, the organochlorine and the organophosphate insecticides are the stomach poison insecticides, and the BT, that is the insect bacteria, is also act as a stomach poison insecticides. Next one is the contact poisons. This contact poison it enters into the insect body through a different opening or natural opening of the insect body like a sutures, membrane, and the tracheal system. In that, the nicotine, pyrethrum, quinol, phos, malathion, synthetic pyrethrats are the contact poison. Next, fumigants. Fumigants means are those chemical compound which is volatile at ordinary temperature and sufficiently toxic to the uh, insects. That is the fumigants. Here, the example is methyl bromide, hydrogen cyanide, ethylene bromide, aluminum phosphates are the different fumigants mostly used against the insects. These fumigants it directly act on the respiratory system of the insects. It enter into the insects through a spiracles and kill the insects. Next category is systemic poisons. The chemical when you apply to the plants or the soils are absorbed by the foliage and roots and translocated through the vascular system and cause the death of the insects feeding on the plants. It is very effective against the sucking type of mouthparts insects like a aphid, jacid, thrips, whitefly, mealybug, and scale insects. That is the dimethoate, imidacloprid, folate, and carbophoron are the systemic insecticides. Next category is based on the mode of actions. It means that how the insecticide is when the insecticide is enter into the insect body, how the insect is killed. In that, the first category is physical poisons. In that physical poisons, the chemical which can kill the insect by three ways: asphyxiation, it means that exclusion of the airs, moisture stress, and the mechanical injury. In that, the some of the oils and the inner dust, charcoal, or clay we can use to kill the insects by an insect. It will be killed by means of physical action. Then protoplasmic poison, toxic and responsible for the precipitation of the protein and destruction of midgut epithelial called as the protoplasmic poisons. Example is mercury, copper, and formaldehyde. Next category is respiratory poison. The chemical which block the cellular respiration, inactivation of respiration and the respiratory enzyme, that is the anoxia. Example is hydrogen cyanide and carbon monoxide act as a respiratory poison. Nerve poison, the chemical directly affect on the nervous system. For example, organophosphates, carbamates, organochlorine, pyrethrum, and the nicotine. And last category is chitin inhibition or chitin synthesis inhibitor that inhibits the formation or synthesis of the chitin in the insect cuticle. Example is difluvengeron. Next is based on the chemical nature. In that, the insecticides classified into two categories: inorganic compounds and organic compounds. These are some of the inorganic compounds like arsenicals, fluorine compounds, sulfur, lime sulfur, barium carbonate, and zinc phosphates. Then, in case of organic compound, that is the hydrocarbon oils, animal origin, plant origin, and synthetic organic compounds. So, let us see one by one. The first one is organic compounds. That compounds do not contain the carbon atoms. In that, the mostly used, that is the arsenicals. In that arsenicals, it is used in a poison bait, that is the Paris green is used as a rodenticides. Then sulfur, the sulfur it is available in the form of both formulation, that is dust as well as the vegetable powder formulation, and it is used as a acaricides as well as the fungicides. Then next is lime sulfur, it is mostly used against the sucking pest. Then barium carbonate, it acts as a rodenticides. Next category is organic compound, that is nothing but the man-made and containing carbon atoms, and in that the first one is the hydrocarbons oils. In that there are two basically oils, mineral oils and coal tar oils. In that mineral oils, that is nothing but the transparent or colorless oils, and it is derived from the secondary rocks. And the coal tar oil, it is a dark liquid, it is a byproduct of the coke or coal gas from the coal. Okay. The mineral oil, the example is the white oil, paraffin oil, kerosene oil, petrol lubricant, like that, and it is mostly used to for treating and preserving the wood. Then coal tar oil, in that is mostly used in a borer solution to control the bark borer or stem borer. Then next category is animal origin insecticides, is nothing but the organic compounds, and this animal originated insecticide, it is isolated from the marine annelid, that is the Lubrineris heteropoda and the Lubrineris viscera, and the toxic compound present in this, that is the Neris toxins. This Neris toxin, it is available in market in the Cartap. Toxin is a Cartap and trade name is a Fadan, and it is very effective against the Lepidopteran pest, and it is mostly nerve poisons. Then these are the some of the next categories: botanical insecticides. Botanical insecticides means the some of the toxic compound which is isolated from the different trees or different plants. That toxic compound which act having a some insecticidal properties. In that, the first one is the neem. The neem contains a azadirachtin, that is the toxic compound which is having a insecticidal value and which is isolated from seeds and the leaves. Then next is the rotenone. In that contain the rotenone compounds and which is isolated from roots. Sabadilla isolated from the seeds of the this plant, that is the Soniquella officinal. The rhinodine compound, Rhinus speciosa, it is a scientific or botanical name. Then this isolated part, that is the woody stem. Then tobacco contain the nicotine. Pyrethrum contain the pyrethrins, which is isolated from the dried flowers of the chrysanthemum. These are some of the botanical insecticides mostly used in the IPM techniques. Then this all the botanical pesticides, it is effective against near about all the pests. This is the chart which show the different botanical insecticides used against the particular pest. Next category is that is the synthetic organic insecticides, having a four subcategory, that is the organochlorine, organophosphate, carbamates, and the synthetic pyrethroids. The first one is organochlorine or the chlorinated hydrocarbon. It contains or it includes the DDT, BSC, and cyclodine compounds. The DDT analog, that is the dicophol, is an acaricide that is very effective against the spider and mites. Then BHC, that is the benzene hexachloride. In that the linden, it is mostly used in control. Linden is nothing but the one of the major isomers of the BSC, and it is control the store grain pest. Then next is cyclodine compounds. It includes endosulfan, aldrin, endrine, dialdrine, heptachlor, and chlordane. They are near about the all the organochlorine insecticides near about the ban. The endosulfan it is banned permanently at the end of the 2011. Why this organochlorine insecticide is banned? Due to the persistent in the soil, resistant in insects, fish toxicity, and the serious environmental hazard is being banned insecticides. Next category is organophosphate insecticides. It is used in a large scale for the agricultures due to their high efficacy against the different insect-based populations. These are some of the examples of the organophosphate insecticides. In that, the monocrotophos shows a some acariciidal activity and dichlorophos shows the fumigant in action. Next category is carbamates. Having a broad spectrum insecticides, it includes carbaryl, carbofuran, phenoxycarb, aldicarb, and thiodicarb. It is effective against the different insect-based population. Then here the synthetic pyrethroids. Insects tends to develop the resistance to against the synthetic pyrethroids. Cypermethrin is a synthetic pyrethroids used as an insecticides in large scales commercial agriculture applications as well as in a consumer products for the domestic purpose, and these are some of the examples of the synthetic pyrethroids. And then now this is the new category, that is the novel insecticides or new group insecticide which having a novel mode of actions. It includes the first category is neonicotinoids having the imidacloprid, acetamiprid, thiamethoxam, and thiocloprid, which is available in the market with a different trade name, and it is used nowadays mostly against the different insect-based population. The next novel insecticide, that is the spinosins. It is the isolated from the actinomycetes, that is the Saccharopolysphaera spinozy, and commercially available as a spinosad, and it is a broad spectrum insecticides against the different caterpillars. Next category is ivermectin, also isolated from the derived from the Streptomyces ivermectis, and this is nothing usually used against the leaf miner, spider, and the mites. This ivermectins includes abamectin and imamectin benzoates. Next category is oxidizines. In that, the indoxide carb nowadays mostly used against the insects which have developed the resistance against the synthetic pyrethroids. Next category is phenylpyrazoles. In that, the fipronil, this fipronil it is mostly used against the thrips. Next category is diamides. In that, fluvenamide, chlorantraniliprole, and cyantraniliprole are the different or mostly used insecticides nowadays. Next category is carotap hydrochloride. This is the animal originated insecticides. Next is new pyrethroids. In that, the lambda-cyhalothrin mostly used. Then these are some of the examples of the new acaricides, that is the phenazogin, propergate, spiromycin. These are some of the examples of the novel insecticides. And the last category is insect growth regulator, that mostly attack on the endocrine system of the insects, and it affect the immature stages of the insects, preventing them from the maturity. No additive side effect is shows. It includes insect juvenile hormones or juvenile hormone mimics and the chitin synthesis inhibitors. In that, the methoprin, phenoxycarb, novaluran, pyriproxyfen, lufenuran, difluvenzuran, buprofezin are the different IGR or chitin synthesis inhibitor is mostly used. Next category is fumigants. This fumigants it is mostly used for the fumigation purpose. In that, the carbon disulfides, hydrogen cyanide, naphthalene, methyl bromide, ethylene dibromide are the different fumigants used. Then there is one typical example, that is the chlorofecrin. That chlorofecrin called as the tear grass is nothing but the fumigant. Next is nematicides. This nematicide is mostly used against to control the nematodes. This is nothing but the non-insect pest. Mostly the carbamate insecticide it is mostly used as a nematicides. Next is rodenticides, the chemical which is mostly used against the rats and rodents. It includes zinc phosphide, warfarin, bromidiolan, and aluminum phosphide. In that, the zinc phosphide it is available in a bed formulation. Warfarin it is warfarin and bromidiolan are the anticoagulant type of insecticides. Rodenticides. Then aluminum phosphide it is the available in a tablet form, and this aluminum phosphide it is mostly used to fumigate the rat burrows. Then the classification of insecticide or pesticide based on their toxicity level. Here, this is the color triangle, that is the red, yellow, blue, and green. The red triangle shows the extremely toxic insecticides. Bright triangle shows the highly toxic insecticides. Blue triangle shows the moderately toxic insecticides, and the green triangle indicates the slightly toxic insecticides. The extremely toxic insecticides having a LD50 value, that is the less than 50 milligram per kg. Then highly toxic insecticides having the 51 to 500 LD50 value. Then moderately toxic insecticides having the 501 to 5000 milligram per kg LD50 value. And in case of slightly toxic insecticides, the LD50 value is more than 5000 milligram per kg. This is the categories of the insecticides. Then the next is, that is the formulations. The formulation is nothing but the that is the which contain the active ingredient and the some of the carriers or solvent. Okay, in a market nowadays different formulation is available. The formulation, it is categorized into two major category: dry formulation and the wet, or sorry, liquid formulation. These are the some of the examples of the dry formulation, that is the dustable powder, wettable powder, soluble powder, water disperser granules, bait, fillets, and microcapsulated. Then liquid formulation insecticides includes emulsifiable concentrate, solution, suspension concentrate, concentrate emulsion, micro emulsion, aerosol, soluble liquid, liquid fluids, and the oil dispersion. This is the different formulation. In that formulation, we can use the different adjuvants, and adjuvants is nothing but the there is a supplementary agents which do not contribute directly toxic to the effect of the pesticides, but are used for improving the physical condition of the pesticides, so that pesticide become more effective in action. And these are some of the examples of the adjuvants we can use in the insecticide bottle with the main active ingredient. This is also some of the examples of the adjuvants. Okay, thank you.